So in this video, we will learn how to convert a binary number to an octal number. And here we have an example, 100111. So the first step is to group them in groups of 3, starting from the right. This is a very important step or part where you have to start from the rightmost. So here, your first 3 digits will be 111 and the next 3 will be 100. Now write them separately. So 100 and then 111, and now we need to convert these into decimal. And how do we do that? It's pretty simple. 1 2 4 here, and here will be the same thing. And now we add the numbers which we have the ones for, and don't add the ones which are zeros. So here we have a 4 and a 1. So 4 times 1 plus 2 times 0, which is 0, plus 1 times 0, which is also 0. And here we have all ones, so it will be 4 plus 2 plus 1, which is 7. And that's it. The answer is 47, and you can write an 8 next to the number, a small 8, not a large 8, because this is to indicate that this is an octal number, and octal stands for 8. So basically it is a 8 base number system. Meaning that any of the digits can have any value from 0 to 7, because there are 8 digits including 0. So it can only have 0 to 7, any of the digits. It can never have 8, by the way, just keeping that in mind. And yeah, that's it. So here we have 8 ones. So again, let's start from the base step to group them in groups of 3, starting from the right. This is a very important part, and you will understand why now. So first 3 are these, and then next 3, and you realize we only have 2 more digits left. So just group them for now, the last 2, and here we would just have 1 and 2, and we wouldn't have a 4 since this is automatically 0, and we don't need to include that actually. And now imagine if you started grouping from the leftmost. So if we did that, let me just write it quickly again. So these will be the first 3, and then this, and then this. So that is not going to be right since it's going to be 4 and 2. So again, just keep that in mind always. So now let's start adding them. So this will be 1 and 1. The next 3 are these, and then the last 3 are these. And if it helps you to write a 0, it's your choice. So anyways, I'll just include the 0 for now. So now we just need to add them. 4 2 1, 4 2 1, and 4 2 1. This is 7, this is 7, and this is 3. So the final answer is 3 7 7 and 8, to indicate that it is an octal number. And that's it. It's pretty simple. So you can pause the video and try to do this example yourself. So let's start again. This is the first 3, this is the next 3, this is the next 3, this is the next 3, and these are the last 2, and you can add in 0 because that does not matter. So now let's start converting these. So this is 1 and 2, 2, this is going to be 7, this is going to be 1 and 2 and 4, so 2 plus 1 is 3. Here we have again 3, and the last one is just 7, and the final answer would be just 2 7 3 3 7 8. You don't need to include this 8, by the way. It's just your choice to indicate that this is octal number, because if you write a decimal number, this could also be a decimal number if you just leave it like this, and it could be a 10. So it's just best practice to write that 8. Anyways, so this is it. So take your time and pause the video to do this example. Now, if you can do this example, then you're a master at this. So again, let's start from the rightmost here. And one thing to keep in your mind is that you cannot skip the right zeros. You can only skip the left zeros. Let's say you have 0 0 0 1. You can skip these. But if there's a 1 here, then you cannot skip these. If there's zeros between ones, and you cannot skip any zeros to the right also. So let's start here. So this is the first 3 digits. Let me actually write these very close to them. So you need to be very careful when you're grouping them. So I'm gonna write them even with more space here. So this is the first 3, this is the next 3, This is the next three. Here you go, and then here, next three. Oops. Next three, next three. Oopsies. Yeah, yeah, and then this, and then we have a 0 1 left to the right most. So now you can start converting them to decimal. So the first one will be just 2, 0, 1 and 0. It's just 2, since this is 2 and 1, and 4 is right there, but there's a 0 below it. And then next is just 2 again. Next one is 4 plus 1, 5. And if it helps you to write that down, I mean, it doesn't, you're more than welcome to write it. So it's just 4 plus 1. Here is going to be 4 plus 2, 6. This is going to be 2 plus 1, which is 3. And here is 4 plus 1 again, 5. It's just 3, 1, 2 plus 1, 4, 1, 4, 3, and 0. So this is the final answer. And if you got this right, then you're a genius. And as always, I do have a method on the calculator where you can just type your binary number and it will give you the number in octal immediately. So I will be making a short video on that, and I can even talk about it right now. So open your calculator, and your calculator should have the option of base minus n in your menu. So you go there and click on that, and then you click on binary. And let's just take a small example, since there is a limit on the calculator how long a binary number is. So let's just take these four, this part only. So just type on your calculator 001, 100, 011, and then 000. So I'm just doing that 001, 100, 011, and 000. And then you click on equals to, and now you should have a oct button also on your calculator which says OCT. And once you click on that, it will say 1430, and there might be some like extra zeros over there, so that you can ignore. As I told you before, zeros to the left, you can ignore them. And this is the final answer, and we know that we also got it right. So that's it. I will be making a video on this, short video, since it's more easier to see something rather than talk about it, of course. And thanks for watching. See you next time.